All right, well, let's just get started because I want to make sure Steve has enough time to present on commercial heat pump water heating solutions. My name's Shelby. I am a program manager with the City of Palo Alto Utilities, and I oversee our business energy advisor and business electrification technical assistance and our commercial rebate programs. Next slide, please. There we go. Okay, so just a quick background on the City of Palo Alto Utilities. We are a small municipally owned utility here in Palo Alto, and we provide all services, including water, sewer, electric, gas. We cover storm drain and also fiber optics. We have a little over 30,000 customers, and we've been in business for over 120 years. And the city has pretty aggressive sustainability and climate action goals where we want to aim to reduce carbon emissions by 80% below 1990 levels by 2030. So a lot of the programs I manage and also a lot of the things that the group I'm a part of within the utilities department works towards directly impacts the city's sustainability and climate action plan. Next slide, please. So the two programs that we're covering today that are related to heat pump water heating in the commercial space is the Business Energy Advisor and Business Electrification Technical Assistance. We partner with ClearResult, who is joining us in for this webinar. Steve is a part of ClearResult's engineering team, and we all work on these programs together through the Business Energy Advisor. This directly supports small businesses in Palo Alto, generally around or under 50,000 square feet. We provide free assessments and ongoing technical support with any projects or efficiency upgrades related to energy, gas, or water. And then the Electrification Technical Assistance Program is very similar to that, where we provide an assessment, we provide a report with recommendations, as well as ongoing support for projects where you're transitioning off natural gas and switching to efficient electric alternatives. This is generally around water heating, which we'll talk about today, space heating, and sometimes kitchen equipment as well. Next slide, please. So one incentive for those who are here in attendance for joining this webinar today, we want to thank you for your support and also your partnership with the city and helping us reach our sustainability and climate action plan goals. So those that are here today, we are offering a boosted incentives for specifically heat pump water heaters. So if you are transitioning off of natural gas, if you have a gas tank water heater right now, and switch to heat pump water heater, generally we have our standard incentives dependent on the size of the water heater itself. So as you can see here, our standard incentives are anywhere between $2,500 to $3,500. And if you are in attendance today and also get the project done by the end of this year, we will offer a boosted incentive that is double that. So anywhere between $5,000 and $7,000, dependent on the unit size. I do want to add a note here that through our Business Energy Advisor program, which is more of just efficiency, if you already have an electric water heater at your facility and you upgrade to heat pump water heater, we will also honor the double rebate for that. Just note that those rebates are custom calculated. And so whatever that custom calculation is, we will double it when we provide the rebate. I will also note that all rebates are capped at total project cost, so you cannot go beyond that and make any money off of this. So you'll either get the full incentive or whatever the total project cost was. I will go ahead and to the next slide, please. Here's my contact information for those who I don't know already on the webinar today. Please, take a photo of this, and we'll also have the slides available and the recording available on the city's website afterwards. So you can always go back and look at this. If you're interested in anything, feel free to reach out to me. I also want to take this time to quickly introduce Sarah. She is on the BEA and BTAP team on the CLEAR-Results side. She's heavily involved in all these programs, so I just want to give her a moment to introduce herself, and then we'll kick off the webinar from there.
Thank you so much, Shelby. Yeah, like Shelby mentioned, I work on the BEA and BETAP or technical assistance programs here with Shelby and with the city of Palo Alto. My name is Sarah. I'm the account manager, so I would be the person who, if you are interested in ever scheduling that free site assessment that Shelby mentioned, I would be the person who schedules those things, and I would work with you and go over reports with you, and Shelby's often there as well. So we try our best to help you out, especially in situations like this or projects like this where you might be installing a heat pump water heater. There is a lot of bidding and everything involved in that, so we're always happy to go over bids with you, and I'd be the main point of contact for you if you do ever have any questions. But I'll go ahead and I'll pass it over now to Steve, our engineering manager. He will be going over the heat pump webinar information with you. So without further ado, I'll hand it over to you, Steve.
Thank you. My name's Steve Brand. I just turned my video on for a minute so that everybody could see me. I'll turn it off again. I don't got the greatest bandwidth. I'm an engineering manager for CLEAR-Result, and our team does a lot of work. We have several engineers in the Bay Area, and we do a lot of work with Palo Alto. So our agenda today, we'd like to cover the basics of the heat pump water heater and the different ways of getting rebates for one. I'm going to start with the electrification program, although as Shelby mentioned, there's another pathway to get this if you have either a resistance electric water heater, a standard electric water heater, or an old inefficient heat pump water heater, like some of the first generation stuff. So I will talk about that briefly. We're going to review heat pumps in general, look at heat pump water heaters, and then look at the efficiency savings and rebates according to the calcs, and we'll look at benefits and challenges for this technology. So really quickly, I'd like to go over the electrification program. Again, and this is only half of the story. The water heaters are down here, and that's what we're looking at today. And this, you don't need to take screenshots. I'm going to summarize it in depth coming up. But you can see that they're pretty robust rebates, and they're doubled at the moment. So water heaters, this is electrification. So this is taking a gas water heater and going to a heat pump water heater, electric heat pump water heater. There's some custom. This is a kind of a throwaway slide. But this is the whole electrification program on these last two slides. Now the audit program, this is only about half of the measures available in the audit program. I took the gas measures out. And what I wanted to illustrate here was that you can get to rebates either from having an electric water heater or from having a gas water heater. And either way, there's the possibility of getting a rebate going to heat pump water heater. We're not talking about boilers today. We're not talking about space heating. We're talking about domestic or service hot water to wash your hands, take showers, wash dishes, etc. This is a pretty nice installation of a Lochinvar, one of my favorite brands for boilers up here in the mountains. This is a standard heat pump water heater. The heat pump is on top in this head, and the rest of the system is pretty much the same as any other tank water heater. So let's take a look at heat pumps and what generally they do, what they are. So our typical refrigeration cycle, your air conditioner, we're pumping heat from the indoors outside. So what comes out of your coil indoors is cold because we're taking the heat out of that and then we're exhausting it. So the air coming out of the top of the condenser unit outside is going to be warm. So we're basically just pumping heat from one place to another with mechanical energy. And if you look at a heat pump for a reversible heat pump, these are what's called heat pumps in common usage. This is basically the same thing with a couple reversing valves in it. And so what you're looking at here is we have it in winter operation. It's pumping heat from outdoors into the building. So this would be summer operation up here on the left, and this is winter operation. Same thing. It's a reversible heat pump. So so what it's doing, it's pumping against nature. Nature wants to equalize. If it's 30 degrees outside, it would like it if it was 30 degrees inside, and vice versa. If it's 110 outside, eventually the heat wants to move inside and equalize with the outside temperature. And we fight that with either heating or cooling. Now, the different types of heat pumps here, scientifically speaking, they're all heat pumps. They're all pumping heat. We don't call them that, but that's what they are. The air conditioner is unidirectional. Blue means cold cooling. So the air conditioner is unidirectional. The heat pump or reversible heat pump is bidirectional. Like in the summertime, it's cooling, and the wintertime, it's heating. A refrigerator is unidirectional. It's always pumping heat out of your freezer cabinet and then circulating that cold air into the refrigerator cabinet. And then you have the one piece of equipment here that is solely a unidirectional heating piece of equipment. That is a heat pump water heater. It's not reversible. It only works in one direction, and it draws heat from the air and uses it to heat water. And knowing how heat pumps work from the previous slides, that means that we have cold exhaust air. I want to bring that up early. It is one of the challenges of heat pumps, and we need to manage that or capitalize on it. It can be quite a nice thing to have. So this is the heat pump water heater. Now, again, we just show the air conditioner up here where we're pumping heat from indoors, outdoors. We're cooling the air indoors. Here, we're pumping heat into the hot water. And so this condenser unit is wrapped around a water tank or immersed in a water tank. And the evaporator is in the head on the top, like we saw in that Lochinvar unit. So that unit draws air from the surroundings, pulls the heat out of that air, and then exhausts cold air into the space. And so, as may or may not be obvious, the warmer the air in that space that it draws in, the more efficient the compressor and the whole refrigeration cycle is going to be in heating up that water. Now, what's noted here is the backup electric resistance heater. There are a lot of hybrid units on the market, and those hybrid units are actually, with factory programming, are actually performing quite well, very high efficiency. So you're going to see some more of that. It doesn't necessarily kill your efficiency, which it definitely has potential to do in space heating with a heat pump. The resistance heat can really drop your efficiency. Here, they've figured it out. They've got the electronics to only run it when absolutely necessary. And that would be where your room temperature is very cool. There's not a lot of heat in it, or it's in an outdoor closet. So there's not a lot of heat in the air being circulated through. And there's a demand for hot water. A bunch of people are taking a shower. Well, they can throw on the electric resistance heaters and kind of, that's your backup. So this is the heat pump water heater. Your condenser is in the water, your evaporator's on top. In your air conditioner, your evaporator's in the house and your condenser's outside. So it's the exact opposite. Now let's look at some solutions for using these water heaters. Now, this is a business, small business program. And we, there's lots of uses for water heaters in a hotel or an apartment complex or a restaurant. And so the idea is, what can we do? Where are these things appropriate? What can we do with heat pumps? Now, the first thing is, why would we even want to do a heat pump water heater? What's the benefit? And the benefit is pretty clear when you look at the Energy Star, graph here. So the blocks below the one line, that's 100% efficiency. And nothing of the three traditional water heaters are meeting that efficiency. Even the electric one, where the electric resistance heater itself is 100% efficient, you still have tank losses, circulation losses, etc. So even that can't meet 100% efficiency. But the way heat pump works is it's using that mechanical energy to boost boost the heat from one spot to the next, and with highly efficient systems, it can become quite efficient. We're talking like 3.3 to 4.1 UEF. That's 4 times the base resistance heater, and that's why we're going this route. It's giving a lot more hot water for a lot less energy, and there's a lot of savings. So it's a very hot item right now, no pun intended. So 1-for-1 replacements are where people's minds go first, and that is just taking out the water heater you have where it's currently located and replacing it with something about the same shape and hooking up the pipes and hooking up the wires and then walking away. And it's completely possible. There's a few things to consider though. If you're replacing a gas water heater, there may not be an available circuit to supply the energy for that new water heater, that new heat pump water heater. It may need a 20 amp or a 30 amp 240 volt circuit, whereas your old water heater, even if it even had a outlet, was probably 120 volt standard outlet sitting next to you right now, standard outlet. So there is a chance you may need to pull a new circuit. If you had an electric water heater, you probably have a viable circuit. It's probably more than enough power to supply the new equipment. Even if that new equipment is hybrid, where it has that resistance backup heater in there, like a 4500 watt backup heater, your electric water heater circuit is probably just fine. So that's really nice. You don't have to do hardly anything if you're taking out an electric water heater. With gas, you might have to do a few things, pull that new circuit. Other considerations, the piping connections should be pretty much the same. Your flow rates, your recirc pumps, if you have them, they should remain pretty much the same. The heat pump water heaters won't require a condensate or exhaust flue system. So that is something that people get used to with high efficiency gas water heaters, is you've got to neutralize the condensate and you've got to get it out of the building or run it to a drain where it's not going to eat away the metal in that drain because it's highly acidic. Hopefully it's neutralized by then. And your exhaust flues, whether it's metal or plastic, is no longer needed. We're not burning gas. And one other thing to mention, there may be a drain system, but it's a different kind of condensate. It's a coil condensate. So it'd be the same sort of drain you would have on a air conditioner coil in your attic. That's the kind of drain if you need one. It's pure water, it's fully distilled, but it wasn't distilled from exhaust gases, so it's not that super acidic water. So it would be the standard conditions of an air conditioner drain. The last bullet is it's going to draw heat from the surrounding or ducted air and exhaust cold air. And we've got to consider that. If this is in a closet off, the living room in your house, there's a chance you may not want it pumping cold air into the living room in the middle of wintertime. Alternately, if you put it in the corner of a data center or an MRI room where there's always hot, I know those are weird examples, but it's something we run into repeatedly. That's perfect, because now it's always too hot. It's always cooling, even in the dead of winter. It always needs cooling, and here you are supplying cooling to the space whenever somebody draws hot water. And you're supplying warm air to the water heater so that it's running more efficiently. Whereas if it's 20 degrees outside and it's in an outside closet, it would be running very inefficiently. And so there's a lot of considerations about where are we putting it. There's one other consideration I should have put on this. It's on a different slide. But where are we going to put this where we're not going to freeze out the space in the winter time? We don't want it cold. But at the same time, can we get it in a warmer space than an outdoor closet in the winter time where it gets very cold? And the fifth bullet that should be there is noise considerations. So when we ran a study on heat pump water heaters in mobile homes, this was several years ago, so the technology's probably improved a lot. The biggest complaint we got was noise, that the high-pitched whine of a compressor can be disruptive if it's not well insulated. Um, the newer products, I'm sure, quite a bit more quiet because they hear the complaints and they react. But it is something to consider. Where are we putting this? Are we putting it in a mechanical room? Probably no problem with noise. Oh, we put it in a laundry room. Okay, how far is that laundry room from the bedrooms and the living space? So just things to consider. So here's just another quick look at these heat pump water heaters. The one on the left is the same one I showed you in the one of the first slides. That is a pure heat pump. Um, I don't think it's hybrid because it's only plugged into the wall with a 120 outlet. They don't take a lot of horsepower unless you put in resistance backup elements. And that's what the middle unit is doing. That's a hybrid water heater. And these are, I'm sure this is a Home Depot. Yeah, Home Depot ad for a hybrid water heater. It's looking at $375 a year in savings. Completely lines up with the calcs we do. This is just kind of their marketing and what it looks like. You can see that the stamped metal grate here, that's either an inlet or an outlet. So that's either where the warm air goes in or the cold air comes out, and the other side probably has exactly the same pattern on it. This one has that ability to accelerate the recovery time with these resistance elements here and here. And that, when you have a situation where you get large draws, but not every day, not all the time, like these periodic large draws, that gives you the ability to meet a large draw. The recovery time might be longer, especially if this is an outdoor closet and it's 40 degrees outside. It's going to have a hard time recovering this tank quickly with just the heat pump. And so that's what those elements are for. And these have been known to have a 3.8 performance factor, EUF, and that's phenomenal, even with the resistance. And so that is something to definitely consider if you might have those large draws or quick recovery requirements. Now, the last one on the right here is something that we're pretty excited about, and in some of the larger business applications. And this is like, this lets you get that evaporator away from the water heater. So the water heater is really just a tank with a condenser in it. And the evaporator can be put in the next room or outdoors or somewhere else where it's not cooling the space that the tank is in or drawing air from the space that the tank is in. Because you might need the tank in a laundry room and you don't want to freeze out the laundry room. So you put this outside and then it'll use the outdoor air to evaporate the refrigerant and discharge the cold air and not freeze the space. The other alternative, and this is, more attractive than sticking the water heater in the corner of a data center, is to put the evaporator in a data center. Because people get pretty upset about having water around electronics or electrical stuff. So doing this, there's no water in this. This is a refrigerant evaporator, just like those. It looks like a condenser, but it's an evaporator. And you can put it anywhere. And if you have a constant cooling load, you have a constant heat generation in a space year round, throwing this in there, it's free cooling. It's free cooling and the whole system works better. The heat from that space is being drawn into this system and pumped into the water. It's a really great synergy for, like I said, data centers, imaging spaces in hospitals, things like that. So this is something that's very exciting to us. There's several companies piloting these. They do exist. We haven't seen one being installed yet, but we've been dealing with a lot of very small businesses, and this is probably possibly a stretch. So let's see, how are we doing on time? Good. One other thing to talk about before we go too far is tankless water heaters. Now, a lot of people, their existing water heater, their gas water heater is a tankless water heater. And there's a lot of pros about tankless water heaters. Most obviously, there's no storage losses. If you go out of town for 2 weeks, the thing never kicks on. You don't use any gas for 2 weeks. The other pro is it never runs out of hot water. It's instantaneous. So a whole bunch of people come to visit. This thing will kick on and do showers all day long. It doesn't matter. The cons are there's a cold water sandwich, which I don't know if you guys have heard about it, but if you jump in the shower after somebody else and you turn this on, there's usually a chunk of cold water that'll pass through the water heater before it gets back up to heat. And that warm water is going to turn cold for about 3 or 4 seconds before the rest of the warm water arrives. And I think some of the manufacturers have worked on recirc solutions to this, but just so you know, that has been an issue. And also that there's a high demand on the fuel. So you sometimes have to upsize your gas line just to get these water heaters enough gas to work. The equivalent amount of BTUs, whether it's from gas or electric, right, is what's needed to heat. And your electric wires start getting real thick if you try to run some sort of device in that will heat water as quickly as a tankless water heater, usually using resistance. There isn't really a replacement, a heat pump replacement that does the things that a tankless water heater does. You can put together a system that will emulate it, but you're not going to find a tankless heat pump water heater. And so some of the questions we like to ask if we see a tankless water heater on a site is, what is the use case? Why do we have a tankless water heater here? A lot of times they'll just say, oh, well, it was the most efficient water heater we could get our hands on. Not that we needed endless hot water or we were worried about energy losses when we were out of town. This was sold to us as the most efficient solution for what we're doing. And we have to ask the question, do we really need it? Does the use case actually justify a continuous hot water heater? And if you're in a laundromat, probably does. There are solutions, but if we can find a different approach where we can come up with a heat pump plus a storage tank or something, we may need to get rid of that tankless water heater. It might be a harder sell too. So the questions are, is there enough daily demand or spikes in demand, and could long demands be met in a different way? And we'll talk about that in a few slides. So go to the next slide and talk about, I beat this subject to death. I apologize, but it is quite important that people understand this. The waste heat on your air conditioner is warm. The waste air on your water heater is cold. We have to keep that in mind. Have to keep in mind the location, the cold air, what can we do with it? And there's a couple of solutions for that. One, we can duct air to and from that water heater. We can duct it from the data center next door, or we can duct it from the outdoors. That keeps this space that the water heater's in unaffected by the cold exhaust air. Maybe that's a desirable thing. You can see these drain pipes. That's your condensate drains for the evaporator unit that's on top. And then the alternative was that remote evaporator, where we put the evaporator outdoors or in another space, and then the condenser inside that water heater is indoors or in some space that you don't necessarily want to freeze out with the exhaust from this. So those are two solutions for keeping the space the water heater is in from getting too cold. If it's a space that's always warm, always too warm, always needs cooling, I wouldn't worry about it. But if it's a small space with very low volume, it's probably going to get cold pretty fast. If it's a space where people are trying to do laundry, it's going to be uncomfortable. So just consider where am I getting my warm air from and where am I exhausting my cold air to? Okay. then this is the storage conversation here. So with the larger draw, let's say an apartment complex with a central water heater system, the larger draw, like everybody gets up at between 6 and 7 and everybody jumps in the shower. So every morning there's a big draw, and traditionally what they'll do is throw a 300-gallon gas water heater in there, and then if it's not sufficient, they'll throw another one in there. Well, it's kind of cost prohibitive when it comes to tank heat pump water heaters. They generally run up to about 75 gallons, sometimes 100, and it's expensive. It's more expensive to purchase the initial equipment. Now we're getting great rebates here. If we could find 300-gallon tanks, maybe we could make it all work out. But as you saw in the thing, 75 gallons is the top tier, and they get quite a bit more expensive as you go above that. And so the idea would be that do we really need something that, more and more heat pump, or do we just need more hot water occasionally? And if that's the answer, if I just need hot water in the mornings, then I can put a 300-gallon storage tank in, and the heat pump can work on heating that tank all day long. And then in the morning, that tank gets depleted and it gets heated up again. And so that's a buffer tank. And a lot of companies make them. I have some A.O. Smiths here. And it's funny, hotwater.com. They have a funny name for their site. They come in different shapes and sizes. These are well insulated tanks. And so the thing about tank storage water heaters, going all the way back to when they started them, is those losses from that tank. You heat up a tank with 140-degree water in a room that's 70 degrees or 65 degrees. Well, the heat wants to equalize. And so they put insulation on it, on that tank between the outer and inner jacket. And that's okay. It slows it down. Then people would come and put blankets over that, and that slows it down more. And so the insulation is important. It definitely reduces those tank losses. Let's see. And so, yeah, that's what I wrote here. I didn't read it word for word, but the idea would be that if we could have that buffer tank to meet those spikes in demand, then we don't have to put in as much water heater. We could do a 75-gallon water heater with a 300-gallon buffer tank. And its job would be to keep that buffer tank warm and recover that buffer tank over the course of a longer period of time. And yeah, it's a solution for when you have those larger draws, but you don't have a constant larger draw. Now, if you have a large draw all day long and all night long, yeah, you're going to need a big stack. You're going to go 1 for 1 on those heat pump water heaters, possibly have to get extra ones. And then you're also going to be affected when you're on the edge of supplying the hot water that you need. Your wintertime operation, unless you have a source of warm air for those heat pumps, your wintertime performance is going to go down. The amount of hot water it can generate in the wintertime is going to be less, except for, using those resistance makeups. And so constant high loads is a different conversation from periodic high loads. We can address that with storage tanks. Constant high loads, we need more heat pump. We need more horsepower. And you're actually going to get outside of the realm of water heaters and into boilers at that point, and that's a custom calculation, just so you know. All right, let's look at some of the numbers. So the structure of the rebate program is based on gallons right now. It may shift. I mean, we're discussing, different structures, but right now, the 45 to 55 gallon tanks, $2,500 per water heater, double that with the current rates. 55 to 75, 3,000 or 6,000 for now. And then above 75 gallons is going to get you 3,500 or 7,000 for the temporary boosted rates. The efficiency requirements for the rebate program is a go, no go check. If you're doing that 40, that should say 55, not 50. The 45 to 55 gallons should be 3.31 or higher. The slightly bigger, 55 to 75, would be 3.33, and then above 75 would be 3.42. So that's just the rebate conversation. This is the requirements. You get a 60-gallon tank. So right in between these two, that's a $3,000 rebate, but that 60-gallon water heater better be 3.33 or better in EUF, in the efficiency, which is getting easier and easier to do. The most recent ones are quite high EUF. Now, alternately, the amount of energy you're going to save per year is a different conversation. And we get that from the California Public Utility Commission's ETRM savings calculations. And those are, they let you choose from a 3.3 EUF, 3.5, or 3.75. So they're really talking, the calculations we do for them are really talking about how much savings are you going to get per year. And when you get a report from us, it's going to talk about, we recommend a 3.75, and here's the savings for that 3.75 for the size for your project. And this is what that looks like. So, as you'll see on the 60-gallon tank, regardless of which efficiency I choose to buy, I'm getting the same incentive. Same for the 50-gallon tank, same incentive. But my savings are going to change the more efficient I go, the annual savings. And so when I'm up at the 75-gallon level and doing the 3.75, the highest efficiency tier, talking $1,000 a year in savings, energy savings. And this is from the electrification model. So this is assuming you're coming from a gas water heater. So yeah, here's the gas savings. The high draw to 50 gallons. So this is basically a tankless water heater being removed and a 50-gallon heat pump water heater. That's just how they modeled it. I'm sure that you might want to put a 75 in or something, but that's the numbers we have to go with right now. Hopefully they'll update them. And the savings show a bit on the lower side because of the efficiency of the tankless water heaters, but you're still looking at a $2,500 incentive. Now, if you're going from a high draw to a 60 or 75 gallon, you're going to get a bigger incentive. And we'll probably have to work out, what the savings might be. These aren't guaranteed savings. These are estimate what we think the savings are going to be based on the CPUC modeling. But the gas reduction is going to depend on that. That's the heat pump, tankless water heater. So that'll probably stay the same. So that's how the system works. We can calculate different savings for the different efficiencies, but the incentives are tied to the water heater sizes at the moment. Okay. When you get a report, and I've done two here. When you get a report, the top box is what the business case would look like for a gas water heater going to a heat pump water heater. I believe this is I want to say I did a 60. Let's see what I did. I know I did the same 506. So this is a 50-gallon. This is a 50-gallon water heater. I got the lower incentive because I went smaller. Or that's what I had. I had a 50-gallon water heater. I went to a 50-gallon heat pump water heater. I'm looking at cost savings of about $500 a year. And my project cost, according to CPUC, is $2,800. So most of it's getting paid off. 88% of it is getting paid off by the incentive. With the double incentives, the maximum is $5,000, but it'll be capped, not at this, but at the cost to you. So the invoices you supply us, you say, no, it didn't cost us $2,800. It cost us $3,200 to have this water heater installed. Well, that's still under $5,000. So that would be reimbursed. We provide the useful life. It's currently at 10 years because that's what the warranties are set to, but they could last longer than that. The quality is going up and up. The natural gas reduction is based on the assumed size of the water heater and the building type that it's coming out of. And then we take that number and we look on Energy Star websites to pull off you know, the equivalent gallons of gas burned in a passenger car, or metric tons of CO2 equivalent, 4.5. Because that's the impact of an electrification measure, is you're reducing your carbon footprint. You're getting away from gas. You're getting rid of your gas, your flat gas fees, if you can get rid of all the gas on your site. But when we look at electrification measures, we're looking at GHG impact. Now, for an audit measure, where I've found an electric water heater, it's 50 gallons, and I run it through the audit tool. There's no natural gas savings because it's an electric water heater. My electrical savings, it's saying that I got about 10,000, almost 11,000 less kilowatt hours per year generating the same amount of hot water. My incentive is calculated, and again, it's calculated based on the lifetime kilowatt hour savings. So this number times this number times a formula. And it's really close. It's it's right about $2,500, and that would be doubled, capped. And then we have the energy cost savings per year, because we're saving a lot of electrical, and electrical is expensive. And so this is what they're looking at, the energy cost savings on a 50-gallon tank, according to the CPUC calcs. Now, everybody's results may vary. If you have a water heater in a restaurant, but you never use hot water, the CPUC is going to assume the amount of hot water you use based on the fact that you're a restaurant in climate zone 4, Palo Alto area. And one restaurant's going to use a lot more hot water than another restaurant. So these numbers are never going to be precisely what you're going to save or what you're going to cost. These are from the studies that have been done. So I like to make sure everybody's aware of that. All right, and we're going to go on to the last section here, and that is the benefits and challenges. And it's a lot of reflection of what we've already talked about. With the heat pump water heaters, lower energy bills, whether it's electric or gas that you came from, lower energy bills, carbon footprint reduction in both cases. Lower electric energy bills is the same thing. It's definitely carbon reduction, but lower gas, eliminating a gas bill, that's a big deal. Eliminating gas use is a real good impact on your GHG. Eliminating a gas service is possible. We recommend you do that if you don't need gas anymore. Don't keep it around just in case. It can cost quite a bit. We've come across buildings where they didn't cancel they got rid of all their gas appliances, and they didn't cancel their gas account, and so they were just getting charged, and it's up to the customer to say, hey, I'm done. I don't need gas anymore. I did what you guys wanted. I switched over to electrification. I've electrified my whole building. So eliminating gas service can have its benefits. And then the other benefit is that chilled air exhaust, that cool that comes off of the top of that thing, can be used to your advantage to reduce the load on your air conditioner, to reduce the load on your whatever cooling system you have, by adding the free cooling to a space. Now, the challenges are exactly the flip. That chilled exhaust air can chill an indoor space. If it doesn't need cooling, it can make that space cold. It can cause issues. In cold climates, not a big deal in Palo Alto, but in a colder climate, if you were up here in the mountains, it's 20 degrees outside. It's going to be having a hard time finding heat to put into that water. And so cold climate operation is a bit of a challenge, but the hybrid water heaters are doing a really good job addressing that. Supplemental heat impact, not that big of a deal. It's not as big of a deal as it is with space heating with the heat pump. So it's on the list because it does impact, but they've done a pretty good job keeping it manageable. And then it can be noisy. It can disturb people if it's in the immediate area. And so that's basically the whole thing. I have one last slide for Q&A. If anybody has any questions.
Yeah, I'll go ahead and jump in. We'd like to invite anyone who's on the webinar right now to go ahead and unmute themselves and speak up if you feel comfortable doing so. I think it could be interesting hearing, who else is on the call with us today. If you have a business here in Palo Alto, what size, if you're considering a water heater project. Um, I think that could be interesting to start a conversation around. And also, of course, if anyone has any questions, feel free to just go ahead and speak up now. You could also, if you're more comfortable with putting the question in the chat box, you can also do that. And we'll be happy to answer it that way.
Hi, Steve. I have a question. Hello, everyone. I'm Hiromi Kelty. I manage our commercial teams at City of Palo Alto Utilities and have worked with Steve for many years, and I always appreciate his expertise. One thing I wanted to add is when he was talking about eliminating gas if you're not using it anywhere else in your building. There is a monthly service charge for having gas service to your building. And that it depends on what rate schedule you're on. Shelby, can you let us know how much that is?
Yeah, currently, it's if you're on the smaller service, so a G2 rate, this is generally for small and medium-sized buildings. The monthly fee is $170, give or take a few cents. But yeah, it's fixed every month, whether you use gas or if you have zero therms in consumption that month. So
Yeah.
even in the summertime, when you're not maybe using space heating and you just have a small water heater that barely uses anything, your consumption charge for gas may be just a couple dollars, but you're still paying $170 every month. So there's a huge savings if you do eliminate gas on your property.
Yeah. And if
And
you're a
then
bigger building,
yeah, I was just about to say that. I forgot. The larger customers, their monthly fee is upwards to $700.
Yeah.
And that's for like commercial industrial size buildings.
yeah.
And just to interject, I did run across a smaller building. It had been on a lower rate because it's probably an older rate. It was only about $105 or $110 a month, and they had used one therm over the past 3 years.
Oh,
That therm
Mhm.
cost them $3,700,
oh,
and it might have just been
Yeah.
a bit flip. It might not even have been actual gas use. And
Yeah,
so,
that was probably the fee.
yeah, it was the fee just, but there was one therm in the record, and all the rest was fees. And it's like you got to pay attention. The less energy you use, the less gas you use, the more it costs per therm as a blended rate, where we just take the dollars and divide by the therms. And if you're not using a significant amount, those flat
it
fees,
adds up. Yeah.
yeah, they add up.
Yeah.
And so the less you use, the better, the more, the better idea it is to try to switch away from gas
Yeah.
altogether and get
So
rid of those
I
flat
think
fees.
it's a little bit misleading because gas prices look low on the
Yes.
surface, but you need to consider these monthly charges to your bill, whether you're using a lot of gas or even a tiny bit of gas, which is not considered in the per therm rate. And I just want to make a plug for City of Palo Alto's electricity, which is very clean and it tends to be a lot cheaper than our neighboring utilities. And so electrification particularly makes sense in our city. Steve, my question to you is how large can we go with the heat pump water heater? Because I'm thinking some of the businesses, maybe small businesses, but maybe they use a lot more water than like 80 gallons or 120 gallons. I see a lot of.
I've seen 100. I don't know if I've seen 120.
Okay. Okay.
And I think the argument, the cost starts pushing you towards a boiler with a storage tank.
Okay, yeah, yeah.
Yeah.
So
But,
anything above 100 gallons, a heat pump water heater may not make sense.
it might, yeah, and the alternative is if you have like 150 gallon gas water heater, maybe 275s will do the
Yeah,
trick.
two of them. Yeah, I've seen that happen in buildings as well.
Yeah.
Okay, and my other question is, what is the availability? I know a lot of these heat pump water heaters are 240 volts, but what is the availability now of 120 volt heat pump water heaters? Because I know there were some on the market, but I don't know how, common they are.
There's quite a few. They're typically not hybrid.
Okay,
They're targeting residential,
okay,
but that doesn't mean you can't use them
okay,
in commercial. We use tons of residential equipment in commercial buildings.
yeah.
Yeah, the residential market still sees a lot of heat pump only, no resistance backup water heaters with a 120 volt plug.
And so that means, though, that the recovery time is going to take longer because it's this power going to the machine. Okay.
Well, the recovery time is going to take longer, but it's also a function of the supplier. And so on a very hot day, you can have a pretty quick recovery, but on a cold day, you can have a very long one
Yeah.
because you don't have that resistance heat to make up for it.
Okay. Well, I'll make a plug for heat pump water heaters. I have 3 of them. I have one in my home, and then I have 2 rentals, and I have heat pump water heaters that were installed, I want to say like 10 years ago now.
Wow.
And they're all working great.
That's
I mean,
wonderful.
I've never had an issue of anyone saying there isn't enough hot water. And yeah, so I'm looking into putting another one in, but the cost is not going to balance out with the amount of usage. And also the rebates, these kinds of rebates are not available for my use case. So this is a great opportunity.
No, and that's a great mention though about the usage. If you have an office building that has no showers, has super low hot water draws, but they just went ahead and put in the 75-gallon gas water heater anyway,
Mhm.
you might be better off with some under sink Ariston, 1.5 gallon or half-gallon Instahots.
Yeah.
Um, and I don't know if we'd be able to incentivize that, but the massive amount of money you would save doing that would justify it. Absolutely.
Wait, what brand did you say?
Well, Ariston is one of the brands. They're just
Okay.
these brands, they make these tiny little water heaters. They plug into 120. They heat up one half to 1.5 gallons of
Mhm.
water just for hand washing at that sink.
Yeah, because there are some buildings where that's all they need the hot water for is hand washing.
Yeah, and so piping it around, circulating it, having a central water heater, it's
Mhm.
what they do, but it's not what they need. They
Mhm.
probably would be better off with the under sinks.
Mm. And how big do these under sink, and these would be on-demand electric water heaters?
They would be on-demand electric with a very small tank. Yeah,
Okay.
they're size of a sewing machine, let's say. Looking around at what I can
Yeah.
compare it to.
And
Sewing
up to how
machine.
many gallons do those make sense? Like 5 gallons or?
No, these are one
Oh,
half a
these are 1 or
gallon
2. Okay, really just for hand washing
hand
then.
washing. They
Yeah.
recover pretty quickly.
Okay.
Yeah.
All right. Yeah. Does anyone have any questions? All right. Well, I mean, if any of you on the call are interested, you could give Sarah or Shelby a call and they can help you with the process or answer questions you might have. I think the most important thing is your use case well suited for a heat pump water heater, and I think they can give you guidance on that.
Yep.
But yeah, I mean, heat pump water heaters on the residential side are all the rage. And we really think this makes sense for a lot of our smaller commercial customers. So this is a great opportunity. These kinds of rebates don't happen very often. So I'll turn it back to you, Shelby.
Yeah, well, if there's no other questions or any comments or feedback at this time, I think we can go ahead and wrap up. As I mentioned earlier, probably in the next week or so, we'll have the recording on our website. If you're ever on the City of Palo Alto website, there's a search bar and you can typically type in like commercial webinar, and then any upcoming webinars will come up then, or our past archive section will as well. So yeah, we'll get this on the website. So if you ever want to refer back to it, and like Hiromi mentioned, if you have any questions or are interested in getting a free site assessment at your facility, please reach out to myself or Sarah. Really anyone on the ClearResult team or myself can help you with getting that started. So feel free to reach out to us and we'd be happy to help. And thank you, Steve, for a great presentation. It's always super informative and we appreciate your time. So yeah, I'll go ahead and close it out and we will see you at the next webinar. Thanks, everyone.
Thank you.
Thanks, y'all.
Bye.
Take care.
Bye.
Thanks, everyone.
Bye.
Bye.